morning, everyone, or I suppose it could be evening when you're watching this. What you guys are going to be doing is finding the trig ratios. So it's using SOHCAHTOA words. So again, sine of an angle, I'm using theta. Theta, again, is just a Greek letter, is your opposite over your hypotenuse. Tangent, I don't know why I jumped to tangent, but here we go, is your opposite over your adjacent. So that leaves your cosine of theta is equal to your adjacent over your hypotenuse. And I apologize I didn't go in the SOHCAHTOA order, but there you go. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent's opposite over adjacent. Alright. They ask you to find the sine of A. So the first thing you have to do is stand on angle A and find the sine. Sine is your opposite over your hypotenuse. Okay, so this is your opposite side, this is your hypotenuse. So the sine of A is equal to your opposite over your hypotenuse. Alright, now notice the wording here that says simplest radical form. It means you have to reduce the radical. So if you remember, 75 is 25 times 3. And this, you can break this into two separate roots. Square root of 25, square root of 3. The radical of a product is the product of the radicals. Square root of 25, you know, is 5. So that's 5 square roots of 3 over 10. This will reduce now to 1 and 2. So your answer is square root of 3 over 2. That's your answer. You don't need to physically break it this way into this format. But what you need to recognize is the square root of 25 is going to come out as 5. Okay? We're going to do plenty more here, so if that was a little confusing, hold on. We'll get to a couple different styles. In this one, it says find the exact value of the cosine of A. So no decimals. You don't type it in your calculator and get a decimal. Cosine of A. So you're going to stand on A, cosine. Cosine of A is going to be your adjacent side over your hypotenuse. So the cosine of A is equal to adjacent over hypotenuse. Notice it doesn't have a radical, but you just reduce the fraction. So there's a 4 in those, so would that be 2/3? And you're done. So when they say simplest radical form, don't get tricked. It doesn't. The answer doesn't have to have a radical. Find the tangent of A. So the tangent of A is going to be your opposite side over your adjacent side. Oops. So from A's point of view, that's your opposite side, and your adjacent side is going to be the 5. Done. Again, it doesn't have a radical. Okay, most of them do. So we're going to practice more of the radicals here. All right. Find the exact value for the sine of A. Sine is your opposite side over your hypotenuse. So the sine of A is your opposite over your hypotenuse. All right. This is different than the first one we did. The first one we did, the radical was in the numerator, and all we had to do was reduce the radical. In this one, the radical's in the denominator. That creates a problem. First thing you need to do, because there's a big old rule that says you can't have any radicals in your denominator, is you need to get rid of it. And how you guys did that is you multiply the bottom and the top by the square root, in this case, of 85. Not to make too fine a point on it, what you're multiplying here, you guys, is something that's worth 1. So really what you're doing is 7 over the square root of 85 times 1. So I haven't changed its value. It's still 7 over the square root of 85. Multiply across the top, 7 square roots of 85. Remember, this does not distribute inside. It stays outside. Over square root of 85 times the square root of 85, it's just 85. If you want some proof in the pudding here, let's see, this calculator. So let's clear this. So square root of 85, come out of the square root, times the square root of 85. So the square root of 85 times the square root of 85. It's just 85. Okay. Look and see if this will reduce. I can't imagine 7 is going to divide into 85. So 85 divided by 7. Nope. But now you also have to look, will this square root reduce? So you have to look at 85. I'm going to prime factor it. 5 is going to go in there 17 times. So this does not reduce. Well, what do I mean by something that would? Back to that 75. That 75 would reduce in the very first problem because there was a perfect square hanging out inside it. 85 only breaks into 5 times 17. Neither of those are perfect squares. So it's just breaking into pieces that are prime. They're not going to have anything that pops out, where 75 did. So this is your final answer. How do you type that into Delta Math? You just have 7. They give you a square root symbol. So you would take the square root, 85, then use your diagonal key, 85, to get the division symbol. Okay, that's how you type it into Delta Math. Okay. Find the sine of A. Sine would be the opposite side over your hypotenuse. So the sine of A is your opposite over your hypotenuse. We got the square root in the bottom. So just like the last problem, I'm going to multiply the top and bottom by the square root of 45. So that gives me 6 square roots of 45 over 45. Now you're not done for a couple reasons. One, this has to reduce. And two, this square root of 45 does reduce. So looking at the square root of 45, it's kind of like that one we did, the square root of 75. Well, that was 25 times 3. Square root of 45 is 9 times 5. And 9 is going to pop out as 3, so this is 3 square roots of 5. So coming back over here, there's a multiplication symbol here. 6 times 3 square roots of 5 over 45. Okay. This 3 will reduce with the 45 and give you 15. The 3 and the 6 and the 15 will also reduce. So that leaves you 2 and 5. So your answer is 2 square roots of 5 over 5. That's your final answer. Okay? You have to reduce the radicals and get rid of the radicals. If it's in the bottom, the word was rationalizing. Then you also have to reduce the radical, if it's possible. Okay, the cosine of A. Cosine is adjacent over hypotenuse. So the cosine of A is equal to the square root of 63 over 12. The square root isn't in the bottom, so I don't multiply the top and the bottom by the square root of 63. All I have to do is look, can I reduce the square root of 63? Square root of 63 is better known as 9 times 7. 9 will pop out as 3, so it's 3 square roots of 7. So this would be 3 square roots of 7 over 12. 12 and the 3 reduce. They'll give you square root of 7 over 4. So that would be your final answer. Exact value for the cosine of A. Okay. So the previous problem was a cosine of A, and we ended up with a radical on top. And that's all we had to do was reduce the radical and reduce the fraction. This is still a cosine, but the radical will be on the bottom. So the cosine of A is your adjacent over your hypotenuse. 7 over the square root of 50. So this time the radical's on the bottom. So I multiply the top and the bottom by the square root of 50. So I get 7 square roots of 50 over 50. 7 and the 50 aren't going to reduce, but 50 will. Sorry, the square root of 50 will. That's 25 times 2. 25 will pop out as, oops, 5 square roots of 2. So coming back, and there's a times here, 7 times 5 square roots of 2 over 50. This reduces to give you 7 square roots of 2 over 5 goes into 50 10 times. That's your final answer. 7 square roots of 2 over 10. The 2 and the 10 can't reduce because that's inside the radical, and this is outside the radical. Okay, playing with tangent a little bit. Tangent is your opposite over your adjacent. Tangent of A is your opposite side over your adjacent. I've got the radical in the bottom, so I've got to rationalize it. Square root of 52, square root of 52. So I have 12 square roots of 52 over 52. Sure, this is probably going to reduce, but so will this. It doesn't matter to me when you start reducing, if you want to do it straight away. So let's see. 52 divided by, will 4 go into it? Yep. So if you wanted to start reducing right away, a 4 goes into this 3 times. And what did I say, 13 times? So I have 3 square roots of 52 over 13, but I still have to do the 52. I still have to do the square root of 52. I don't recognize right away what goes into there, but 2 and 26, 2 and 13. It looks like it's 4 times 13 is 52. So 3 square roots of 4 times 13 over 13. The 4 is going to pop out as 2. So you have 3 times 2 square roots of 13 over 13. So I have 6 square roots of 13 over 13 is my answer. Okay. I know that's a lot. You guys haven't reduced radicals in a long time or rationalized them in a long time. If you guys have questions, please come to the office hours to get some help. Miss you guys. Stay healthy.